Hey, so I'm going to go through a couple of these questions for you on this review. FunZone offers 4 party packages. The prices for each package are $50 more on the weekends and weekdays, as shown in the price below. Okay? So which statement best describes the relationship package number price? So if I look at package number, remember, we're asking if it's a function, and a function can't have its x's repeat. And it says right there that package number is the x. So if you look here, there's a 1, 1, 2, 2, 3, 3, 4, 4. Each of these numbers is repeating one time. So this one is not going to be a function because each package price has 2 different prices, one for the weekday, one for the weekend. So not a function because we got 2 1s, 2 2s, 2 3s, 2 4s. Here a function is defined by f of x equals 6x plus 1.5. What is f of 2.5? So that just means I'm going to put this 2.5 in here for x. So 6 times 2.5, if you have a calculator, is 15. 15 plus 1.5 is 16 and a half. Which one represents a line with a slope of 0? So hopefully, again, you have a calculator that can graph. If you don't, I would suggest using Desmos.com. That's a great calculator. So we're looking for something with a slope of 0. So this has a slope of 2 because it's 2x. This has a slope of negative 1/2 because it's negative 1/2 x. These two are kind of tricky. If you have an x equals, you're going to have a straight up and down slope, and we call that slope undefined. If you have a y equals, you have a straight horizontal slope, and that's what we call a slope of 0, is when horizontally from left to right, because you're not rising any. So that's going to be our 0 slope. So when it's y equals something without the x. Lee believes the graph shows a direct variation. Why is Lee incorrect in saying the graph shows a direct variation? So right here, when the x is 0, the y value is 1, because remember it needs to go through 0, 0 in order for that to make sense, and it doesn't. It goes through 0, 1. Nate went on a trip. He used a table of values to repeatedly record the time he had been traveling to the distant starting point. Function represented by the table is linear, and the rate of change is 50 miles per hour. Which statement is correct? Alright, so it looks like we're trying to find the initial value. So, after 1 hour, he's 50 miles away. After 2 hours, he's 100 miles away. After 3 hours, he's 150. After 4 hours, he's 200 miles away. So what we keep doing is adding 50 each time. So to go backwards and find the initial value, instead of adding 50 each time, we would need to end up subtracting 50 each time. We're not multiplying by 50, because that would turn into 2 hours, we'd be at 250 miles, and if you went 250 miles in 2 hours, you're going pretty fast there. So to find the initial value, we would end up subtracting 50 each time to go backwards to find when it was 0. Hope that helps.